All right, here's example 4. We've got the graph of f of x equals square root of 16 minus x squared, which is pictured there. And we want to find two things. We want to find f of 2 and f prime of 2. So f of 2 is just the defined function value, right, at 2. So to get f of 2, we're just going to plug directly into the equation. F of 2 will equal 16, or the square root of 16 minus 2 squared. That's the square root of 16 minus 4, which is square root of 12, or 2 radical 3. So that's just the y value, right? When x is 2, y is 2 radical 3. And then to find f prime of 2, I'm going to differentiate that. So once again, I want to look at the square root of 16 minus x squared, as 16 minus x squared raised to the 1/2. Therefore, the outer function would be stuffed to the 1/2, and the inner function is 16 minus x squared. So to find f prime of 2, I'm going to differentiate that outer function. I'll bring the 1/2 down and then subtract 1. So I'm going to then have 1/2 times that inside function to the negative 1/2, and then times the derivative of the inside. The derivative of 16 is 0, and the derivative of negative x squared would be negative 2x. So there's the derivative. I now want to evaluate this at 2, which means I'm going to plug in a 2. That'll be 1/2 times 16 minus 2 squared, which is 4 to the negative 1/2, times negative 2 times 2, which is negative 4. Whoops. Okay, so if I simplify there, 1/2 times negative 4 is going to give me a negative 2 up top. And then 16 minus 4 is 12 to the negative 1/2, which means I'm going to drop that to the denominator. And I went ahead and rewrote it as a radical so I could simplify. So again, square root of 12 is 2 square roots of 3. So if I write it that way, then the 2's would cancel, and I'd have negative 1 over the square root of 3 for the value of f prime of 2. Now if we continue on to parts B and C, B and C is just looking for the line equation of the line tangent to the graph of f at 2, and then the equation of the line normal to the graph of f at 2. So notice I've just plugged these into point slope. Again, if we look back at the beginning of this example, here is my y1, right? 2 radical 3 is y1. That comes from just regular f. And then the slope of the tangent line comes from f prime, which was negative 1 over the square root of 3. So we have y minus 2 square roots of 3 equals my slope, which is negative 1 over the square root of 3, times x minus 2 for the tangent line. And then the normal line is the line that's perpendicular to tangent. So notice it passes through the exact same point, but it has the opposite reciprocal slope.